post this video. All right, so we are now recording. So yesterday, here's what we did. It was a little intro to a scatter plot, and a scatter plot is just actually a picture. That's all it is. It's a picture of a table. It's a picture of data. So it's a graph that shows the relationship between always two variables. And the one that we did a little more of today was the number of days absent and your mark. Some of the other ones was your tibia length and your leg length, or the distance from the basketball net and the number of baskets you made, or the age of the house and the price of your house, okay? Capacity of a gas tank and the distance traveled. The age of your car and the value. It's always two. When something shows a pattern, we can also call it a trend. A trend is something that happens over and over and over. And from this pattern or trend, you can describe the relationship. Now, Julie had a mom who measured her height every single year on her birthday. And you can see her age is increasing by one, up by one, up by one, up by one, all the way through, which is good. And that's why we have those numbers down on the bottom, because that's our independent variable. On the side, though, these numbers do not increase by the same amount every time. They're increasing, but not by the same amount. Please don't just write these numbers on the side. Notice we created a scale going up by tens in order to get these numbers on here. And when we plotted all the points, we have all of these dots going up to the right. So when you take a look, it says describe the trend in data. The dots rise to the right. I can't stress this enough. Data, dots. Data, four-letter word starting with D, dots, four-letter word starting with D. If you ever asked about the data, just tell me what the dots are doing. Your three answers will be this. The dots rise to the right, the dots fall to the right, or the dots are scattered. Those are the only three options for data. The dots rise to the right, the dots fall to the right, or the dots are scattered. But as soon as you see relationship, you always are going to start by saying, as this variable increases, this variable blank. And there's only three options. The second variable increases, the second variable decreases, or there's no relationship. It stems right to the dots rise to the right, which means increases, falls to the right, decreases, or there's no relationship here, the dots are scattered, means there's no relationship. So if the dots rise to the right, this is going to be increases. If they fall to the right, this will be decreases. And if there's scattered dots, this is no relation. We learned about independent and dependent variables. Our independence on the bottom, our dependence on the side. So in our case, age and height. Okay? Now, today we're going to go one step further. And I'm going to move to this page here. And we're going to talk about trends and interpolation and extrapolation, okay? So take a look at those two words again, interpolation and extrapolation. Those are two types of ways that we can estimate. The big thing we're going to do today is we're going to draw some more scatter plots, but we're going to use them to estimate some values that we don't know. So on your handout, and you should have this in your book, 2.4, as you follow along, to make predictions, we are going to model the data, the dots, with either a line or a curve of best fit. A line or a curve. Now, I would say 4 out of every 5 scatter plots you do, most of the scatter plots, we're going to have a line of best fit here in grade 9. But every so often, you're going to see a scatter plot where you say, these dots seem to be more in a curve than a line, okay? So what are we going to do here? How are we going to come up with the rules to draw this line of best fit? If we're going to draw this line right here, what are the rules for drawing this line? And there's one major rule, and I'm going to highlight this, because if you only follow one rule, this is the one. Draw an oval around your dots, a tight oval around your dots. And that line of best fit must follow that general pattern. So the major rule is draw an oval around your dots and then have your line follow that general pattern. If you only follow that rule, that's enough to get you by. But here are some of these minor little things that you can tweak your line with. You can make your line just a little bit better. You should try to get your line through as many points as possible. Try to make it go through as many points as possible. If you can tweak your line just a little bit to get 1 or 2 more points on it, probably a good thing to do. In most cases, you won't be able to get all the points on your line. Like picture this over here. Let me just go back for a second to our warm-up question. Remember this one right here? I can't draw a straight line and get all of these points on it. So I'm just going to get rid of this. I'm going to get rid of that. Get back here. Right here. Not agreeing with me here. But when I take a look at this, do you see how it's impossible for me to draw a line and get them all on? Like I can't draw a line to get all my points on. But what I can do is I can go right through the middle of that oval. Going to go right through the middle. But if I can just tweak my line up just a little bit, just move it a little bit to get maybe a couple more points on the line, I would do that. Do you see this black line goes right through the middle of that green oval? What I don't want to do though, is I don't want to move this way up here because take a look where all the points are that aren't on the line. Do you see how most of them are below? Whereas if I were to go right here, do you see how almost all the points that aren't on the line are above? You want to spread those equally above and below. You want to go right through the middle of the oval, and I've got a bunch of points not on the line above, but I also have a bunch that aren't on the line below. So that's what I mean right here. There should be an equal number of points both above and below the line. So any points that aren't on the line, try to spread them equally above and below. And then the one thing that I like to do is I make my line go through the entire graph. I don't start at my first point and end at my last one. I go through the entire graph and it saves me a little bit of trouble later on. Okay. So once you get this all copied out, put your hand in the air for me. Perfect. Okay, I'll give those people a quick second to finish copying and then from there, as people are copying, I'm going to take 20 seconds here. Just do my attendance. Okay, so my attendance is done. Hands in the air if you're done. Come on, Olivia, Brooklyn, Hayden, Sawyer, when you guys are done, hand in the air. Should be done by now. Olivia, put your phone away. All right. So here's what we're going to do. We're going to go back to this page right here. This was the one that we did earlier. So I want everybody to go back to 2.3. And this was the graph that we did. Okay, this was the graph that we did yesterday. Now, what I would like everybody to do is take a pencil and don't be pushing too hard, just very, very faintly. Take your pencil and let's just draw a nice smooth curve around these dots. Now it'll be harder for me with my mouse, but we're just gonna kind of go and draw a nice smooth curve all the way around, okay? Don't try to like form around the dots. Don't be going like this, okay? It's a nice smooth oval just around your dots. And that right there tells you exactly the way that your line should be going. So when you take a look at this, your line is going to be going up to the right. So as soon as you have a line going down to the right, you've already kind of gone against the pattern. The major rule says your line has to follow that oval. So I know my line is going to be going right up through the middle of that oval somehow. Now don't draw that line yet. Please don't draw that yet, but I'm just going to kind of get us started. I know my line's going to be going up to the right like this right here. But I don't want to draw it too high where I get those points on the line, maybe 1, 2, 3, 4, 5, But do you see how all the rest of the dots are below that aren't on that line right there? The same goes right here if I have this line too low. I want to get it in the middle, so I'm trying to get as many points on the line as I can with the rest spread equally above and below. And the one big thing, please watch me here. The one big thing is this. If you were to take this oval and extend the oval in the same direction, is your line going to be going right through the middle of that oval if you extend it? That's the biggest thing that you have to keep in mind. If your oval extends in that direction, does your line go in the same direction? Do you see how our line would here? But if I were to have my line something like this, do you see how that line's still in the oval? But if the green oval extended, if this oval extended in the direction that it's going, and this line extended in the direction that it's going, do you see how we're starting to get farther and farther apart? So your line wants to go through the middle of that oval so that if the oval extends, my line extends. And the one last point before you actually draw this is put your line through the entire graph. So do you see how I went through the oval, but I also went through it up here, right to the very end? Don't stop at this last point. Go right through to the very end. And there's your line of best fit. That line represents the data, okay? So grab a ruler, grab the straight edge of your phone, always use a ruler. I'm telling you right now, when we have our little assessment on chapter 2, if I see a line of best fit without a ruler, I probably will not give you the mark, okay? You have to use a ruler, nice straight line, draw your line of best fit here, okay? And when you have that line done, put your hand down.
So we're drawing this on the sheet that's already done, right?
Exactly, Sawyer, the one that you did yesterday. So we're going back to that and drawing a line on it because we're going to use it today to estimate. Okay, so when you get your line done, put your hand down. Okay, a few more people. So the key as people are finishing up is this: draw a nice faint oval. Don't take a pen or a magic marker and circle those dots so the first thing somebody sees is that oval. Just a nice little faint oval for you to use. And then your line basically goes right through the middle of that oval, okay? So if I were to go back, as people are finishing this up, I can just go back. You guys don't have to do this. But if I were to go back to this right here, I think that's a good line of best fit right there. Okay. If I were to backtrack, and even though we didn't have this, okay, those dots right there, if I were to draw a nice faint oval around them, I would have something that looks like this. There's my oval, and my line would go right through the middle somehow to represent that. Okay. If I were to backtrack, the farmer's field, we eventually had our graph that looked like this. Oh, I guess I didn't graph it. I'm going to go back here. Julie's age, we're already going to do the wingspan. Like even right here, these are some good ones to do. When I take a look at this one here and I draw my nice faint oval around it, you can see how this is going to be a pretty easy line of best fit because of how close together those dots are. Line goes right through the middle. There's your line of best fit. For this one here, oval around, and I'm just doing this quick with my mouse. Sorry about that. Hard to do with a mouse. So you've got your oval, and your line of best fit would go through the middle of that oval, somewhere in there. Okay, do you see I've got like 1, 2 points above, 1 down below? That's pretty good. And down here, we're going to get to this in a little bit today, but down here, when I put an oval around these dots, what do you notice my oval actually is? For the age of the house and the price of the house. My oval is actually a more of a circle, right? It doesn't have the pattern like it did up top. Like if I were to tell you which way do these dots go, you'd say up to the right, down to the right. This, they're all scattered. There is no line of best fit here. Do not draw a line. Okay. So do not draw a line of best fit for that bottom one when you have no relation, nothing there. Okay. So now everybody should be done. Sawyer, Carter, Eric, are you guys done? Put your hand down when you're done. Okay. All right, everybody's done. So here's what we're now going to do. We're now going to use this line to estimate. So let's go back to 2.4. Sorry, you're going to be flipping a little bit here. Let's go back to 2.4, the page that we started to copy out today. And we're now going to look at these two keywords right here, something called interpolation and something called extrapolation. We're going to look at these two terms. So it says right here, use your line of best fit to estimate the following. How tall was Julie when she was 5 years old? How tall was Julie when she was 9 years old? So I'm going to do both of these right now. So 5 years old and 9 years old. So we're going to go back to our scatter plot right here. And I know you can go to the table and find exactly how tall she was when she was 5 years old, but we're not going to do that. It says to use your line of best fit. So we go down to the piece of information they give us, which is 5 years old. And I scroll across and I say, there's 5 years old right there. Using our line of best fit, how tall was she? We go all the way up until we hit not the point, but the line. I hit the line right there. And as soon as you hit your line, you are now moving across. And if you had to make an estimation, do you know for sure? Absolutely not. But if you had to make a guess, what would that number be? I would say 108, 109, somewhere in there for me. When you did this on your graph, depending on how your line of best fit looks, you may have 110, 111, or maybe 105, depending on how your line looks. Mine's about 108. And when I estimate for 9 years old, I go over here to 9. I go all the way up till I hit my line. And then I go all the way across, and I'm right between 140 and 150. I would say 144. Maybe 143. It looks like it's just a little bit lower than halfway. I guess my line, I could fix it a little bit right there. Yeah, maybe about 145 for me, okay? So I have 108 and 145. Those are my two estimates. So I'm gonna go over to here. And under my answer, my first one, when I estimated, I had an answer of 108 for me, 108 centimeters. That's how tall I figured she was. And when she was 9, I had about 145. Okay. Next one. How old was Julie when she was 100 centimeters tall? Notice the difference here. Instead of giving the age, and we have to find the height, they give us the height. We have to find the age. So 100 centimeters tall, I go back to my scatter plot. I say, okay, 100 centimeters tall is right, and I'll use blue this time, right here on this axis, not on the bottom, but on the dependent. And I go all the way across until I hit my line of best fit. And I go straight down. And I see that I'm right around 4 years old. So I can go back to my table and I can say she was about 4 years old. And then lastly, how tall was Julie when she was born? Well, when she was born, she was technically 0. So we are going to go here. I'm going to grab my line. I'm going to go right from 0 all the way up. And I'm about 60, maybe 62. So 62 centimeters. And I've just estimated using my line of best fit. Okay. 62 centimeters. Okay. So when you get all those done, put your hand in the air for me. I know you're done. When you have all those done and estimated, now yours may be a little bit different. You may be a little bit off from what mine were. Trust your line of best fit. However you drew your line, that will give you your answers, okay? Okay, so 4 more people, and then I'll move on to this next part, okay? Okay, so 3 more people. Hands in the air when you're done there, okay? Keegan, Hayden, let me know when you're done. All right. Now, the next part is the method of prediction, and this is where we're going to get to the following, okay? Interpolation or extrapolation. We're going to get to the difference between these two right here. Let me explain it first with a diagram, okay? So just watch down here, and I'm going to explain this, and then we'll fill out the top. We'll fill out the stuff up here and all this stuff on your page, but I just want you to watch here for a second, and I think this will make sense to you, okay? This is a scatter plot I just drew down here, and notice we have 1, 2, 3, 4, 5, 6, 7 dots. If I were to take this very first dot and draw a line down and a line over, it's my very first dot in my scatter plot. Do you see how it's the one that has the lowest on each one here? And then on the other end, do you see how this is my dot up to the highest? So I go over and I go down. All I did was I took my first and last dots and I just drew over, and down. So do you notice how all of the dots are between these two? Do you see how all these dots are between these two dots here? If you were to estimate anywhere inside of these dots, anywhere in here or anywhere in here, you're estimating inside your dots because you've got dots on both sides. Do you see if I were to go right here and go up and I go over, do you see how I have dots on both sides of that estimation? Do you see if I go up over here and estimate, do you see how I have dots on both sides of that estimation? Anywhere inside the dots, inside the dots is interpolation. Inside the dots, interpolation. Inside. But as soon as you go outside, then what's going to happen is you are going to have extrapolation. Exterior is how I remembered it. Exterior. So if you were to estimate past this last dot, do you see how you don't have dots on both sides? You only have dots on this side. There's nothing over here. That's called extrapolation. We're past our last dot, or we're before our first dot. But anywhere in these two areas is called extrapolation. So inside, extrapolation, outside. So now let's go up here and let's actually put this down in words. When you interpolate, you are making a prediction inside your data. Interpolation, inside your data. It's the green area of this graph right here. These predictions are usually very reliable. Okay, and I'll explain why in a second. So your hint is you're estimating between your first and last dots. This is called interpolation. We're going to get to that, so you're ahead of me here, okay? Keegan, are you done that table there? If you are, put your hand in the air for me, okay, Keegan? Interpolation inside your data. Now, on the contrary to that is called extrapolation. I just got your message there, Keegan, you're all good, okay? When you extrapolate, you're making a prediction outside of your data. Like when you're outside of something, you're on the exterior of it, okay? You're on the exterior extrapolation. This often requires you to extend your line. Now, do you remember how I said right up here, put your line through the entire graph? A lot of times you can save yourself this little step by just drawing your line through the entire graph. Anyways, you don't really have to extend that line. But unlike the interpolation, which is reliable, these are a little less reliable when you extrapolate. You've got to kind of watch yourself a little bit. And when you extrapolate, you're making a prediction before your first dot or after your last dot. That would be the orange area down here is extrapolation. Interpolation's inside, extrapolation is outside. So here's what I want you to do. I want you to copy out this table. Or sorry, table. I want you to copy out these fill in the blanks, okay, and get them all done. And then what I would like for you to do is I'd like you to go back up to your table. And just like Sawyer typed off to the side, he said, sir, what do we put in for that method of prediction? Well, what you're now going to do is you're going to see if you can determine whether each prediction you did for Julie in her height, in her age, whether it was interpolation or whether it was extrapolation. So if you want, just to be sure, just put a little I or a little E for inter or extrapolation, and then we'll take it up and we'll see if you got it right. And when you have everything copied out on the screen you see, and you went through and you tried your table to get the best you can, just put your hand down. And I know you're done, and we can take it up, okay? Okay, yeah, so Abby, once you get the note finished up and once you copy what's on the screen, all I want you to do is go back up to the middle of this page, and do you see right here, do you see the yellow, or the greens? I guess I'll do it in yellow here. I want you to put right here, are each one of the interpolation or extrapolation? When you estimated for 5 years old, were you inside the dots, interpolation, or were you outside the dots, extrapolation? What about for 9 years old? What about for 10? What about for when she was born? Are each one of these predictions inter or extrapolation? That's what you're going to write right here. Does that make sense, Abby?
Yes, thank you.
Okay, perfect. So I'll go back down here so people can see that. And when you get everything done, when you get the note copied out at the bottom of this page and you've looked at your table and wrote interpolation or extrapolation for each one, just put your hand down. Do a few more people here and then we'll move on. Okay, just give me 1 sec here. I'll be back in 60 seconds. I just have to shut a computer down. My internet just got really, really slow here. So I just got to shut down one computer. You guys finish up. I'll be right back. All right, so that being said, okay, hopefully this speeds up a little bit. Let's go back up now to the table and let's go through each one of these and determine whether it's interpolation or extrapolation, okay? So when we went to 5 years old and I go over to my scatter plot right here, here's my scatter plot and here's basically what I'm seeing. If just as a visual, I don't know, let me just use this line right here. Do you see my first dot here? If I were to go down and if I were to go over, there's my first dot and here's my last dot, down and over. So without getting too crazy here, if I were to just grab my rectangular tool and if I were to start up in this corner and if I were to go all the way down to here and across, and I would just start to here and go over and up, what I'm going to do is I'm going to take these two, this one, and let's go this one, those two, and I'm going to do a solid fill of green, but I'm going to kind of fade them out a bit. So do you see that green shaded area that I just created? Anywhere in there is between our first and our last dot. So we call this interpolation. So when we estimate for 5 years old, here's 5. Do you see how you're in your green area? 5 is interpolation. But as soon as we went to 9, do you see how we're past our last dot? 9 is now extrapolation because we're outside. The next one was 100 centimeters tall. So we go to 100 centimeters. And when we estimated for 100 centimeters and we got 4, we're inside that shaded region. That's called interpolation. But notice when we estimated when she was born, it's called extrapolation because it's before our first dot. So we have 2 inters and 2 extras. So the very first one is called interpolation. The second one is extrapolation. When she was 100 centimeters tall, back to inter, and then when she was born, extra. Okay? No problems? Now, I'm going to explain something here, and I just want you to see if this makes sense to you, okay? Okay, thanks for that, Keely. So let me just explain here why it is that these interpolations are so reliable, but the extrapolations are less reliable. Let me just explain. I'm going to go to a new page, okay? So here's my new page, and I'm going to make a little scatter plot down here real quickly. Right here, and I'm going to do a scatter plot for when my mom marked my height on the wall, okay? So with my ages, here's when I was 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8, okay? So here's all the way up to 8. That's my last dot. And I don't even know, let's just say I was 100 centimeters tall when I was 8, okay? So this is Mr. Bracken's growth chart. Now, believe it or not, I'm a little bit older than 8 right now. And if we were to take this line and extend it to where I am right now, how old I am right now, I would probably be somewhere right around here. I'm not going to give you my age, but I will tell you that I'm probably somewhere right in here. Right there. That's where I'm at right now. So if we drew a line of best fit, I real quickly put an oval around here and I drew my line of best fit and it went up something like that. Then basically what it's saying is my age right now, my height should be, and I'm going to move it over here just for visualizing. Here's where I'm at now. Here's where I'm at when I was 8. I drew my line of best fit. I get something that looks like that. That's a really good line of best fit. And I extend it and take a look. How tall should I be right now? I go all the way up to my line of best fit. I hit my line. I go all the way across, which is going to be over here. Oh, I've got to extend this axis now. If that's 100, then this is going to be about 200 right here. This would be about 300 up here. So I'm about 350 centimeters tall, or 3.5 meter sticks. So if you guys could picture a typical classroom, my classroom is just over 3 centimeters tall. So when you walked into my class and I was teaching, my head would be hitting the ceiling. Hey, it's got to be true. That's what my line of best fit said. Like, I should be 350 centimeters tall. And if I was, I'd probably be playing in the NBA. Okay, I probably wouldn't be teaching. I'd be making millions of dollars by like bending down to put the ball into the basket. Okay, LeBron couldn't guard me because I would be like 3 times the size of LeBron. You know, that doesn't make any sense. Why? Because this is extrapolation. And in this case, after I grew to my height, when I got to my maximum height, I haven't grown in years. Do you see how this is what my growth chart would be? I haven't grown in years. I'm about 176, 180 centimeters tall, I believe. So I haven't grown since I've been like 18, 19. So this line of best fit doesn't continue here. It eventually drops off. Now, when I was younger, I followed that pattern for a while. I grew every year. My daughter right now is 5 and she's growing every year. She's growing and growing and growing, but eventually she's going to stop growing. Okay. So the extrapolation, you've got to be a little worried about. When I estimate past that 8, I got to say, well, wait a second. Does it make sense that I'm 250 or 350 centimeters tall? Something's wrong there. But when I'm young and I've got dots on both sides, do you see the dots are on both sides? Yes, I'm going to be somewhere in between these two. That's pretty reliable, whereas this isn't. Okay. So can you put your hand in the air if the whole reliability makes sense, like before and after? Inside your dots, it's pretty reliable because you got a dot before and a dot after. How would I be like 100 centimeters tall? I go up to 200, but then down to 150. That doesn't make sense. Perfect. A lot of you are catching on here. Okay. So that's the whole reliability. Interpolation, you can be pretty reliable. Like over here, you can be pretty sure that at 4.5 years old, you know, Julie was somewhere between 100 and 110. You can be pretty sure of that. You can be pretty sure of any interpolation. But after you get past the last dot, you got to be worried a little bit. Okay. You got to take that with a grain of salt. All right. So that being said, here's what we're going to do. Let me see what our next page is. Right here. Perfect. I think this is a really good spot to take just a quick 5-minute break. Let's just refresh, grab a drink, use the washroom. We are going to reconvene in 8 minutes, right at 1 o'clock. Okay, so I'm going to put a timer up, and don't be late because I'm going to start as soon as this timer ends. 8 minutes, and if you're back or not, I'm starting in 8. Okay, so take your break. See you in 8 minutes here. All right, we got about 15 seconds here. So if you're back, ready to go, put your hand down. Excellent. All right, hand down. Perfect. Okay, here's how we're going to finish our lesson today, okay? We're going to fill this next page together, the one that starts with correlation at the top. So we're going to fill this one out together. We're going to do one example together, and then you guys are going to be turned loose to a little bit of work for me, okay? When I give you these three scatter plots, now I know you don't see the axes right here, and you don't see the variables right for this one, and then you don't see that for this one. But if you were just to see these dots, here's what I hope you know so far, okay? If I were to ask you to describe the data, data, dots, data, dots. So if I say describe the data, I would hope you would say the dots rise to the right, the dots fall to the right, or the dots are scattered for this one. That's what I hope you would say. But if I were to ask you to describe the relationship, that's when you use the two variables. So for instance, let's just say down here was tibia length and leg length. As the tibia length increases, the leg length increases. Let's say this was days absent and your math mark. As the days absence increases, your math mark decreases. And then this one here is scattered. So let's say the age of the house and the price of the house. You can say there is no relationship between the age and the price of your house. Or as the age of the house increases, there is no relationship with the price of your house. That's how I would think you could describe these scatter plots so far. But we're now going to add one more way called correlation, and it's basically one or two words. As soon as the dots rise to the right, as the bottom variable increases, the side variable increases. That's like two thumbs up. Like if you think about increasing, you think about putting your thumbs in the air. Increasing is up. So two thumbs up is usually a positive thing. So a scatter plot that goes up to the right, a scatter plot that both increase is also called positive, up to the right. But in the same way, this goes down to the right. So when you go down to the right, as this variable increases, this one decreases. This is a negative correlation. Think about one of your hands with the thumb down, negative correlation. And the very last one is when they're all scattered. We call this not positive or negative, but we call this no correlation. So a scatter plot shows a positive correlation when the pattern rises up to the right. This means that the two quantities increase together, your tibia length and your leg length. Then the scatter plot shows a negative correlation when the pattern falls to the right. So this means as one variable increases, the other one decreases. That's like your days absent in your math mark. But then when you have two that really don't have any relationship, the length of your hair and your geography mark, no relation between them. Then you can also describe them as either strong or weak. When the dots are really close together, do you see this? If I were to draw a line of best fit here, do you see how close these dots are together to the line? That's a really strong relationship because the dots are tight. Whereas this one's a little more weak. Do you see how the dots are spread out? So down here, if the points nearly form a line, they're very close together, we call it strong. But if the points are more spread out, they still form an oval, but they're more spread out, we call it weak. And my little hint to you is this: when you draw your oval and you have a tight oval, that means it's strong. When you have a wide oval, still an oval, but it's wide, that means it's weak. And if your oval ends up being a circle, that means it's no correlation. So when I ask about correlation, there's really only 5 possibilities. The 5 possibilities are positive and strong. Maybe I'll do it right up here. Positive and strong. Or you could have positive and weak. So you can have a positive strong, you can have a positive weak. But what's another possibility? Well, you could have negative. So you could have a negative down to the right, strong. You could also have a negative and a weak. And the only last one there is if you have no correlation, not positive or not negative. These are the only 5 possibilities for correlation, okay? Positive strong, positive weak, negative strong, negative weak, no correlation. As soon as you have positive, it's up to the right. As soon as you have negative, down to the right. Strong, the points are tight together. Weak, they're spread out. And no correlation. All right, glad you're here, Torrin. We're on the second page today. So you're gonna have to get caught up there with the video, but just kind of continue from where we're at here, okay? So now let's go through each of these down below and let's draw a line of best fit. And let's describe the relationship with its correlation. So we go over to here and we draw a nice oval around our dots. Nice and faint. We draw that oval around our dots, really faint, so only you can see it. And then we draw a line through it. Right there. Let's describe this thing. Is this positive or negative? Somebody want to help me out here? Positive or negative?
Positive.
Positive goes up to the right. Okay, Sawyer, this one goes?
Oh, up to the left, so negative.
Yeah, so up to left or down. It's always to the right. So up to the right or down to the right. So this is a negative. Like when you're reading from left to right all the time, this goes down to the right. Okay, so this is negative. And it's also, what would you say, positive, or sorry, strong or weak? Because as soon as it's negative, it can be strong or weak.
Weak.
Are the dots pretty close together? This is the very first one. So I guess I should have maybe done one or two first, just so you got the pattern. Now, the dots aren't all on the line, but I would say this is pretty strong because they are pretty close to the line. Compared to this one, Sawyer, that one's a little bit tougher when you don't see it, but do you see this one here? Do you see this one here, how we do still have an oval? But do you see how spread out these dots are right here? I should have maybe done a couple examples here because this does look like this one here. I agree. And I said this one was weak up here. Okay. But you see how they're pretty tight for this one. Let me just get rid of this. There. And when we draw our line for this one, do you notice how our line of best fit kind of goes through the middle here? And do you see how this is a weak one here? But these dots go up to the right. So this is positive because they go up to the right. This is now also weak. Man, if I could spell weak. Okay. This one here, I draw my oval. Here's my scatter plot. I draw my nice vein oval. And what I notice is when I try to draw my oval, do you see how I get a circle? This is no correlation. Don't put weak. It's not no correlation and weak. It's just simply no correlation. We're done. The next one, for the first time, when I just go back a page, you don't have to. Do you remember this right here? Can also have a curve of it, line or curve. For the first time when I take a look at this data and I try to put my nice smooth curve around it, do you see what happens here? Do you see we get this kind of boomerang type effect? This is more of a curve of best fit. So we can't draw a line of best fit here, but if you wanted to, you could draw a curve of best fit. You could kind of draw a curve kind of going through the middle here. That ending part, I wish I would have did a little bit better. Hard to do with a mouse, something like that. Okay. So all we have to say for this one is this is non-linear. This is a curve. Okay. You guys do the next three, or sorry, the next five. Draw your lines of best fit or your curve of best fit. And then what's the correlation? Positive, negative, stronger, weak, no correlation. And if it's a curve, just put curve. Okay, when you get done, put your hand in the air. When you've got all 9 of these done, put your hand in the air. So as you're finishing up, just check your work with what I have here, okay? I think this one right here, some of you may think it's no correlation, but technically there is an oval there. It's just a really big oval. Okay, if there's a point over here or a point over here, then I would say it's more of a circle, but those 2 points aren't there. And even though it's very weak, really, really weak, I do think there's still a relationship there. When those points go away, I think there's still an oval, okay? This one here, I didn't draw my oval around it because, I mean, they lined up in an exact curve going all the way along. Like you could draw an exact curve and get every point on there. So I didn't need to worry about drawing my oval there, okay? And then the last one was like the upside down one here. So when you get done, just put your hand in the air. I know we can move on. You guys are doing so well. This is working out really, really good so far, okay? Almost done. You guys are almost going to be working here, okay? There's just one more thing that I'm going to bring your attention to. Okay, so just a few more people here. When you're done, put your hand in the air. Okay, 2 more people. Okay, so Kaylee and Sawyer, just let me know when you're done. Okay, perfect. So here's what we can now do to describe these relationships. We can say how the dots go, the data, so up to the right, down to the right, or they're scattered. You can talk about the relationship as the one increases, the other either increases or decreases or no correlation. And the last way now is correlation, where we can go positive or negative, strong or weak, or no correlation. Okay, so let's turn the page and let's go to this one right here, renting a house. Okay, so I believe this is the next one in your booklet. Somebody want to confirm that? Is that the next page? I'm going to check mine. Yes, it is. Perfect, perfect. Okay, so let's go through this example together. It says this table shows the average monthly rent of a 2-bedroom apartment in Guelph, Ontario from 1996 to 2003. Now, my cousin went to school in Guelph, and I got this from him a little ways back, obviously, 2003. And I used it in this question. I thought it was pretty neat. So it says to determine the independent and the dependent variables. Well, you guys should know that right now. The very first variable is always your independent, so year, and the dependent variable is the second one, okay? So first question done. Now it says, determine a scatter plot. Well, year goes on the bottom. So I'm going to bring year on the bottom. Average rent goes on the side. And then the title is wrong. I don't know why that's that way. The title is wrong. Okay, I'm going to overdo it. It should be the average rent versus the year. So I'm going to correct that. Average rent it's always the side versus the bottom, okay? So is everybody okay with that part right there? Now, here's where this comes into play, okay? Now, the power of the smartboard here, I'm going to take a picture of this and I'm going to bring this down here. And actually, I'm going to go to the next page. I forgot that I already did this. So now that we go here, we're going to start to look at this scale down here, okay? What can we do as the scale down here? And I'm going to go to this page. I just want you guys to watch, okay? So I think we have the following. Okay, perfect. So I got all these lined up here. Okay, so you guys already have this and just watch, sit back, relax, year, average rent over here. and then we have our title. Okay, so I'm not going to worry about that, but we have these here. Now, here's the problem. I've got to make a scale for the bottom to get these numbers on right here, 1996, 1997, 1998, and so on. So I start and I say, well, I'm just going to go like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way through. What's the problem with that scale? Somebody on mic can talk to me here. I haven't talked to you guys in a little bit. What's wrong with that scale?
It's not showing the correct numbers.
Yeah, like how in the world are we going to get the numbers 1,996 and 1,997? How are we supposed to get it onto the scale? It doesn't even show these numbers here. So I'm going to get rid of this. We're done with this one. So what if I went like this? 0, 200, 400, 600, 800, 1,000, 1,200, 14, 8, 16, 18, 2,000, and so on. Now what's the problem?
We wouldn't be using most of our graph.
If you take a look at these numbers, 1,996 to 2003, these numbers all fit right between these two lines, just below 2,000 and just above 2,000. All of our dots would be right between these two red lines right in here. Do you see that? 1996, 1997, 1998, they would be so close to 2,000 on this scale. Exactly what Rye was saying. We're not using any of this graph over here and over here. Do you guys understand why this graph doesn't make sense, even though we can get, or the scale doesn't make sense, even though we can get all our numbers on? Does that make sense? Put your hand down if you understand why this scale doesn't make sense either. Okay, perfect. So I'm going to backtrack here. And obviously this doesn't work. So here's the problem. This one didn't work because I couldn't get the numbers on. This one didn't work because they're so tight together. It's almost like I need a combination of these two. So are you guys understanding that we actually kind of need this scale right here that we started with? 0, 1, 2, 3, 4, 5, 6, 7, 11. But we don't need any of these numbers. Do you see from 0 all the way up to like 1995? We just don't need any of these numbers. We just need to start at this number and keep going up by ones, and then we have a really good scale. Does that make sense to you? That it's almost like we need to be going up by ones, but we just can't start at 0. So put your hand in the air if that makes sense. This is the scale we want to use, but we want to get rid of all the yellow and just use the green. Okay, so I'm going to put my camera on here for a second because in class, I think this makes sense to you. You can see me teaching here for a second. I'll comb my hair, make sure it's all nice and clean. So here I am, but just take a look here, okay? So my hands are going to represent that scale. And what I'm going to do is I'm going to take that scale, and do you see all the yellow on it? Do you see that yellow that we don't need? I'm going to take that and I'm going to crunch it together. I'm going to take all that yellow and just smush it together. And what that does is almost like in geography, when you learned about earthquakes and so on, it breaks the earth. Like when you push two plates together on the earth, it creates an earthquake and it kind of rumbles up and it creates like mountain ranges. That's what's happening with this scale. We're going to take all the yellow and we're going to push it together because we don't need any of those numbers. We just need to start at the green. So I'm going to be able to crunch this axis by doing the following. Do you see how this right here shows I've crunched all the numbers right here? This shows that I crunched all the numbers from 0 all the way to right before the first number I need. And it creates this mountain range, like this crack in our graph. It's called breaking your axes. So the one that I actually need is this right here. I broke the axes. I'm starting at 0, but all the numbers from 0 to 1996, I'm going to break. I'm going to start at 1996, 1997, 1998, and I'm just going to go up by ones over here. Does that make sense to you guys? Put your hand down if that makes sense, how I came up with that scale. This right here, this yellow, this right here represents all these numbers being crunched together. Okay, awesome. Now on the side, the same thing could happen over here. We've got a big jump up to 658. Like we've got a big jump up to there. but then we have small jumps after. So do you see right here how we actually want these numbers on our scale? Do you see like 600, 650, 700, 750, 800, 850? Do you see how those are the numbers that we want for this? We want to have kind of these numbers, but all of these numbers here, 500, 400, 300, 200, all the way down to 0, we don't need those. We can crunch all these together in the same way. So do you see how I can go like this? And I can crunch those numbers right here with this little Z, this little kind of sideways crack. So I don't need to write all those numbers. I can write this instead, and I'm crunching all those numbers at the start. So this is how I'm going to come up with my scale. And the reason is, do you see from 0, do you see how there's a huge jump to get to 1996? And then there's just small jumps after? And the same here, to go from 0, there's a big jump to 650, but then there's like up by 20, up by 18, or just by 8, up by 18, up by, like there's small jumps from there. That's why we break the axes right here. When there's a big jump at the start and then smaller jumps after. So over here, when we go to our graph now, and you guys can now finish this, when we go over to here, do you see how our bottom scale is going to be this? We're going to break the axes, start at 1996, and go up by 1 year. And the same goes for over here. We're going to break the axes. And I can bring this down a little bit, I guess. I can put 600 on that line. And now we've got scales that are really going to work for the data that was given to us. Okay. The years were only going up by 1, but it just so happened we started at almost 2000. There's that big jump that we're going to crunch at the start. That's all those numbers from 0 to about 1995. And over here is all those numbers from 0 to about 600 are crunched over here too. And it shows like the plates of the earth like buckling to create a mountain range. It's called a break in the axes. Okay. Once you get that done, plot your points. Okay, plot your points and see if you can answer the couple questions at the bottom here, okay? What's your question, Sawyer? You can unmic Sawyer, talk to me. Yep.
I don't get how you break the axes or whatever.
Well, you break the axes, Sawyer, when there's a really, really big jump to your first number in your table. And then there's small jumps from there. Okay, so we didn't have to break the axes on some of the other ones because, you know, with her age, Julie's age and her height, like with her age, it was 0, 1, 2, 3, 4. So we didn't have to break the axes. But do you see how with this scatter plot here, the very first row of our table there with the years, do you see how our first number is 1,996? That's a really big jump from 0. We go from 0 to 1,996, and then we only go up by ones from there. We're doing really small jumps, but it's just a really big jump at the start. So I broke the axes so I can start at 1996. I'm saying every line's worth 1 here. When we jump, the scale is 1, up by 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 1, because our table's going up by ones. But I don't want to start at 0 and go up by ones until I get to 1996, because look at how long that scale would have to be, that axis would have to be before I even get to 1996, Sawyer. Do you see that?
Yep.
So I'm going to break the axes. This means all the numbers from 0 to 1995 are crunched together. I don't need them. I'm starting at 1996 and only going up by ones. Because if I didn't put this here, if this was gone, and I'll just take my whiteout pen here, and if I went like this, if this break wasn't there, then you're saying every 2 lines is worth 1,996. Every line's almost worth 1,000, like 1,000, 1,000. But now all of a sudden you're only going up by ones. How can you go up by 1,000 and 1,000 and then only start to go up by ones? You're going up by something different. But when you break the axes, this doesn't count anymore and your scale is 1. You're just starting at a bigger number. Over here, what's our scale? It's 25 because I'm going up by 25 every time I go to the next line. That's my scale. But notice the first part, I broke the axes. I took 0 to 600 and I just crunched it together. When I plotted this, I got something like this. It's not going to be exact because I kind of did it quickly. Or I guess it would be kind of exact, 658. So I'm just going to move up just a little bit here. But I got a graph that looks something like that. Okay. Okay. So describe the trend in the average rent as the years increase. It doesn't say correlation, it doesn't say data, it doesn't say relationship, but it does use the trend in the average rent in the years of increase. It uses kind of the two variables like years and average rent. So for this one here, I'm pretty sure that I would put as the years increase, the average rent increases. I think this talks about the relationship between the two variables. It doesn't say data, it doesn't say correlation. Okay, so I think I would put as the years increase, the average rent increases. Next, what would you suspect the average rent of a 2-bedroom apartment to be in 2005? There's 2 ways to answer this. On your test, if you just looked and said, oh, I don't know, like maybe around 850, you would probably get 1 out of 2 or maybe 1 out of 3. But if you went like this, put a nice oval around your dots. And I should have had a better oval. And when the dots are very close together, sometimes you can get away with not even doing your oval if you have very tight dots together. Like I can play around with this on my smartboard. You guys, once you draw your line with your ruler, you're pretty much got it. So just kind of move your ruler around until you get what you feel is a really good line of best fit. And do you see how my line there is kind of a really good line of best fit? It says for 2005, so I'm going to show going up from 2005 right till I hit my line. I'm going to go right across and I'm going to say, I don't know, maybe 855, 860, somewhere in there. But using your line of best fit, I think the rent for 2005 should be, for me, I would probably put about maybe 855. And if I saw that, you know, I'll put a $sign in front. But if I saw that on your test there, I would say, wow, that's pretty cool that they drew their line of best fit, they estimated, good for them, you know. They're not just looking at a table and like throwing out, I don't know, 840, 850, somewhere in there. Yeah, you're probably right, but this gives the exact value using your trend, okay? When you get this question done, put your hand in the air. I know you're done, okay? When you get this all finished, hand in the air for me, please. Awesome. You guys are working so well. This is great. Excellent, excellent, excellent. Just wait for Amelia and Hayden, then I'll explain exactly what we're going to do and we will go from there, okay? Perfect. Now, that's it for today. My lesson is done, okay? Today, all I wanted to do was introduce you to a few of the things, and here's what they are. I wanted to introduce you to a line of best fit, and I'll type them right over here real quick, just so you see them visually again. I wanted to introduce you to drawing a line of best fit. Then I wanted to introduce you to interpolation, estimating inside your dots, and extrapolation outside your dots. I wanted to introduce you to correlation, okay, which is positive, negative, and no correlation, and also strong or weak. And then the very last thing that I wanted to introduce you to was breaking an axis. Okay, so I think we've done all that. I think we did the line of best fit, interpolation, extrapolation, like estimating, correlation, okay, and then breaking an axis. So put your hand down if you feel confident with those 4 things that I kind of taught you today. Excellent. Okay, here's what we're going to do. We're going to stay online. You guys aren't leaving. You're not logging out. Okay, I will be here to help you, but here are the 2 things you're going to do. You have 2 handouts for me, and this is your homework for today. And you should be able to get this done before the meeting's done. Okay, so the very first page is this one here. This is the age in your earnings. Okay, now what I'd like for you to do is break the axes on each of these. Okay, so my 2 little hints are break each axis and also draw a line of best fit, not a curve. There is going to be something in this graph where you look at it and say, oh, maybe this is a curve and not a line. I want you just to draw a line of best fit, not a curve. There's going to be, I don't want to give this away, but there's going to be 2 outliers right at the very end. So I just don't want you messing this up, but you're going to have a bunch of points kind of all going up like this, and then you're going to have 2 outliers at the end. Ignore these when you're drawing your line of best fit. Just draw your line around your dots. Ignore those 2 outliers. Draw your line of best fit. Pretend those outliers don't even exist when you're drawing your line of best fit. Does that make sense? So if you have an outlier, if I had this as my graph, I'm going to undo this because I think this is something that I should have maybe mentioned to you. Let's say I had a graph like this. This, and then I had one way over here. When I draw my line of best fit, I'm just going to draw around the parts that make the pattern. And I'm going to draw my line of best fit through here. And I'm going to recognize I have an outlier. That's fine. But there's my line of best fit. I know I've got this outlier here. That's fine. But don't draw your oval to include that, okay? It's going to mess up your scatter plot. So just know it's there, but draw it around the other ones, and that's what's going to happen here. So that's your first one, okay? The second one you're going to do is this one right here, the next page. Now take a look, you've got some decimal values. So once again, break your axes. Break both axes, okay? You're going to break both of your axes here. And then don't be worried if you get it exactly like 0.5 or 0.3 or 0.4. Don't worry if it's not exact, okay? As long as the point is very close, you're going to be okay. All right, so those 2 scatter plots, I want you to complete those. And then when you're done, take 2 nice pictures of them. You guys did a really good job of taking clear pictures. And I want you to upload both those pictures into ESB for me, okay? And we will call it a day. Is that good with everyone? So 2 handouts, pictures, uploaded into EDSB under today, under 2.4, the 2 handouts, okay? And try your best. It's okay to make mistakes, okay? You don't have to get perfect on everything. Just try your best. Mistakes will happen. Learn from the mistakes, and that's how you learn, okay? Is by making mistakes and getting back up. I always use this analogy of Michael Jordan, probably maybe the best basketball player of all time. Okay, Michael Jordan, I don't know if a lot of you probably know Michael Jordan, a lot of his shoes with Nike and so on, like you guys is basically LeBron, right? But with Michael Jordan, do you know he got cut from his high school basketball team the first year he tried out? He got cut from the high school team. Could you imagine if he just pouted and went home and said, I can't believe I got cut from the high school team. You know, I'm never playing basketball again. And he starts to sulk. We would have lost one of the greatest basketball players of all time. He got cut from his high school team. It's incredible. Okay. So don't worry about making mistakes. You're going to make mistakes in life. You're going to make mistakes all the time. Just learn from them. And that's all. So when you're doing these, try your best. And when I take them up tomorrow, you learn from your mistakes and go from there. All right. What are you confused about there, Sawyer? What's confusing you with the broken axes?
So, like, how do you know which number to go from when the axis is broken? Like, how high you go?
Well, you got to get all your numbers on the graph. So everybody, I think, is going to be working. So I can go back here, okay? And I'm just going to kind of undo all of this right here. Okay, so I'm just going to undo this, get rid of that, get rid of that. I'm going to put this back here for a second. So my question to you is this, okay? This would be my question to you right here, Sawyer, to hopefully get this across to you. If you had to fit all these numbers right here, Sawyer, you see these numbers from 1996 to 2003? You see those? If you had to put those onto the scale so you can make a scatter plot, what are you going to do for your scale? Tell me what you do.
I would go up by ones from 1996 to 2003.
Well, you just broke the axes. You know what you're doing. You just broke it.
Oh, so breaking the axes is just starting from a random number?
Well, it's starting from one of the first numbers in your table, the first number in your table. Like we can't do this, right? Just we can't go up by ones. Whereas we can't do this. We can't start at 0 and go up by ones because we can't get the numbers right here. Like I want to get these numbers in green. These numbers right here, I want to get on the bottom axis. And if I started at 0 and went up by ones, I can't get those on. So this doesn't work. Delete. But if I went like this and I went up by 200s, started at 0, went up to 200 and 400 and 600 and 800, I can get these numbers on here, but every single number is going to be so close to 2000 right here. It's going to be right in this yellow strip that the dots are going to be so tight together that we won't even be able to get them spread out. Like we're going to waste all of it. All our dots would be in this yellow strip. Like picture all of our dots like right here. How can you tell if the scatter plot's doing like that? You can't. So this doesn't work. We have to get rid of this. This doesn't work. So what we actually have to do is exactly what you told me. Like you know how to break an axis. You have to go up by ones, but instead of starting at 0, do you see how we have to move down the line and we have to start at 1996? That's called breaking the axis, starting at a number down the line. And the only thing you have to do is put a lightning bolt like this squiggly line between 0 and your first number, and it shows you got rid of all the numbers between 0 and your first number, and now you can go up by ones. Does that make sense?
Yeah.
Yeah. So you know how to break the axes. You just told me that.
Yeah. And for the creating scatter plots and lines of best fit, earnings will be on the left, right?
For this one? For this one here? Sorry?
Yes.
Yeah, okay. So the very first variable goes where? Where does this one go all the time, sorry?
Sorry, could you repeat that?
Yeah, where does that first variable in your table always go?
On the left?
No, the first variable. Age
Oh, on the
goes
bottom.
on the bottom, always on the bottom. The second variable in your table always goes on the side.
Okay. So would it be possible for me to start at 25 and go up by 2, or do I have to go up by 1 when breaking the axes?
You can go up by whatever you want, sir. Okay, you can go up by whatever you want, but you do break it. You do break the axes and you start at 25. You could even start at a number before it, like 24 or 23 or 22. Like you